All right, so it is now the appointed hour. So welcome to today's webinar topic, which is on the need to measure safety instrumented system performance. And this is an area that is of somewhat concern because not a lot of end users seem to be doing performance reviews in terms of how their SIS and their SIFs are operating. So we're going to look at some of the reasons, but also, more importantly, why it's a necessary thing to do. But before that, for those that are not familiar with Exida and who we are and what we do, and I apologize to those that are, but just bear with us. I will just give you a brief introduction of where we are, who we are. So Exida is a company that's set up in 2000, and exida stands for Excellence in Dependable Automation. And it was originally started with two gentlemen who were looking at how to help manufacturers comply with the new standard that had just come out at that time, which was the IEC 61508, for certifying products in safety applications. Since then, the company has grown tremendously. We don't just now do certification for functional safety of products, we do cybersecurity certification for products, and we also do personnel certification. Some of you may be certified functional safety experts or some certified functional safety professionals, and you'll be well aware of that particular process that we go through. Also, we now provide services for alarm management, cybersecurity, and functional safety from the conception or inception all the way through the life cycle. And to help us with that, we also have a suite of enterprise software tools. Some of you, again, may be very familiar with the Excellencia tool and the modules that go inside Excellencia. So this all helps us with providing support for process safety applications, machine safety applications, robotics applications, and automotive applications. And we've also moved away from just being based in the US and Germany to being a global operation. So we are adding offices. Last year we added the Irish office, and we've just officially launched or will be officially launching the Middle East office. So we are continually looking to expand and grow. And the nice thing about the alarm management, cybersecurity, and functional safety is that it's industry agnostic. So in other words, you can apply it to many different industries. And in fact, we've worked in the oil and gas, we've worked in chemical, we've worked in pharmaceutical, we've worked in food and beverage, steel, energy, water, and then also in mining. We do machine safety for those as well, robotics, as I mentioned, and autonomous driving. So a whole range. Anywhere where there's a need for either functional safety, cybersecurity, or alarm management, this can be applied. So how do we measure success? Well, we are the largest agency for doing certification now in the world, and not a lot of people know that. We are actually bigger in terms of the number of certifications we've done. We are also mostly employee-owned now. We've gone away from just the two original founding fathers, if you like, to being more of an employee-owned business, and that was a conscious thing because the founders want the business to continue and grow after they've retired. We have well over 100 experts now globally, and we've done more than 1,000 certification assessments and modeled well over 500,000 SIFs using our Excellencia tool. We publish a lot of books and reference materials, and I always encourage people to utilize the exida.com website because we do provide a lot of information that's freely available. For example, these webinars. Those of you that are regular attendees of our webinars know that we record these and we keep them on the website. So you can go through, select which webinars you'd like to see. You can watch them whenever you want, for as long as you want. And there are YouTube videos. There's no charge. And hopefully that gives a good basis for being able to build your own knowledge. And we cover subjects such as certification for products, cybersecurity, functional safety, as well as personnel certification, and then for functional safety, alarm management, and cybersecurity. So there's a whole range and wealth of webinars and good information. We publish books. These books are available through the website or through, I believe Amazon has them. And the last one we did was the functional safety for managers, what managers need to know. That was published last year. So I always encourage people to make use of the webinars, make use of the website. There are white papers there too, which are free. And of course, we have the safe automation equipment list where you can find certified devices. So if you're looking for a particular transmitter or final element, you can go to the SAEL and do a search and find what's available. Just a bit about me. Some of you may know me already, but some of you may not. I've been in industry now since 1977. I started off as an electronics engineer, working for an avionics company, and then I moved to a safety systems company in the early 80s called Industrial Control Services. It's now part of Rockwell and the Sensia company, which is the joint venture with Rockwell and Schlumberger. I spent 15 years at ICS. I designed products for the emergency shutdown, fire and gas, and addressable fire system, as well as leading the development group for 10 years, and then moved into the automation world in the late 90s, spent 15 years or so in the automation world, and then came back into safety about 9 years ago. So I've been with exida nearly 10 years now. And my role is varied. I'm responsible for the end user business, for the services, as well as one of the primary instructors for the functional safety course. I also teach the cybersecurity course, and I have responsibility for global business development. So that's enough about me. Let's get to the subject in hand. So, this need to measure the safety instrumented system performance. If you are following IEC 61511, then IEC 61511 is what is known as a performance-based standard, as is IEC 61508, which is the base safety standard, IEC 62443, and also the alarm management. So with IEC 61511 being a performance-based standard, it is not prescriptive. So the old standards that were prescriptive, these would tell you what you have to do. They would say, this is what you have to do, and this is how you do it. Double block and bleed, for example. You can't do anything else. That's what you have to do if you're going to be compliant with that standard. The prescriptive standards, there's nothing wrong with them. The only problem is it's, once you've done it, there isn't necessarily a requirement to treat it like a life cycle. So ongoing maintenance and servicing isn't always addressed. With a performance-based standard, on the other hand, it says this is what you have to do, but how you do it is entirely up to you. So you can make use of modern, up-to-date equipment, practices, etc. The only thing it requires you to do is to be able to measure your performance. So we need to come up with key performance indicators, KPIs, that we can use for measuring performance. So if we don't do that, because our safety instrumented system is designed to meet a certain requirement in terms of the amount of risk reduction it's providing, if we're not measuring our performance, how do we know that we are continuing to maintain that level of risk reduction and performance? Because the safety instrumented system will include safety instrumented functions, and these safety instrumented functions will have their own safety integrity levels. And so the safety integrity level has certain requirements, and therefore we need to make sure we maintain those safety integrity levels through ongoing maintenance and testing. If we don't maintain these SIFs properly, what will happen then is that we won't be able to sustain the original risk reduction. And very quickly, in some cases, our performance will degrade fairly rapidly. So it's very important that we do measure our performance. As such, IEC 61511 was updated in 2016 now to include a mandatory FSA 4. So again, the thing to remember is that the IEC 61511 standard isn't written by academics, it's written by end users for end users. So the end user, the committee members, the end user committee members have recognized that their fellow peers are not doing this. So it's now a mandatory requirement. So when it talks about that, it says that we have to carry this out periodically. Now remember, this is a performance-based standard, so it's not going to tell you how often you need to do this. It says you have to do it, yes, but it doesn't tell you how often you need to do it. So it says that an FSA will be carried out periodically during the operation and maintenance phase to ensure that maintenance and operation is being carried out according to the assumptions made during design. So this means we need to be collecting data, identifying what are the key performance indicators that we want to be able to measure, and then determining what period of time we're going to be looking at them. So again, you can look at it as the 5-year window between PHA revalidation, between revalidating your hazards. You could use that 5-year window. If you've not had incidents or problems, that gives you a reasonably good enough amount of time to be able to have done some proof testing, to record the performance indicators, and be able to then go back and compare. So for example, our hazard frequencies that we were expecting, are we within that expectation? Are we getting more problems than we originally thought? So that information, plus the demands made on the safety instrumented system, all of that would be recorded, and we can use that information when we go back and redo the hazard and risk assessment. So again, how do you measure your SIS performance? So people say to me, well, where do we get the KPIs from, the key performance indicators? Well, you can get them as a natural result of creating the safety requirement specification, because the safety requirement specification will have things defined such as the proof test interval. How often are we going to be proof testing? The mission time. Mission time is how long are we going to have the SIS running before major overhaul or replacement. And again, that time will be set and logged in the SRS. Now, this of course means that the operation and maintenance people have to have access to the SRS. And this is another thing we often come across, is that the SRS isn't with the operations and maintenance people. We should be tracking the useful life of the devices, because we should be planning on replacing or refurbishing devices before they get to the end of their useful life. And I did a whole other webinar on why useful life is important, plus a video as well. So there's an extra explains video about why useful life is so important to track. The mean time to fail, SAFE, the spurious trip, for example, that will be defined in the SRS. And so if it says that we don't want it any more frequent than once every 25 years, as part of our SIL verification, when we've done our design, we look at what is the spurious trip for each individual SIF. And as long as it's not below the target, we're fine. But we should be making sure that's the case. So if we've set the target at, say, no more frequent than once every 25 years, and we've had 2 trips in the last year, then something's not right. And we should be looking into what's the root cause, what's causing that spurious trip. Because it could be down to equipment problems, it could be down to maintenance problems, it could be an installation problem, it could be even an application mismatch. That for example, if we've got a valve that's being used in severe service, but the valve wasn't rated for severe service, then the valve is more likely to fail more often, as an example. We could consider use of leading and lagging indicators. So if you're not familiar with what they are, lagging indicators are events that have already occurred. So any demands, any failures, any incidents, any trips, even if relief valves go off, that is an indication of all is not well. So we may not have had any incident, but we should be recording the number of times that occurs and then looking at how we can reduce those. So lagging indicators are things that have already happened. Leading indicators, on the other hand, are indicators that we can use to tell us if we're more likely to have problems in the future. For example, the number of equipment inspections that are overdue, missing the proof test intervals, and also not performing the ongoing personnel assessments. This is something else that was added into the 2016 edition of IEC 61511. We now have to conduct, and again, the standard doesn't tell you how often you need to do it. It just says periodic ongoing personnel assessments. So the operations and maintenance people need to be tested or assessed at a given interval. And again, we might set that interval at once a year. So that would be something else we would look at. Say, are we doing that? If we're not doing that, why are we not doing that? So these would be indications to tell us, if we're not doing it, that we are potentially saving up problems for later on down the line. So leading and lagging indicators can be very useful. Some of the typical KPIs that I've already mentioned, of course, was the proof test interval. The mean time to restore is another one. So typically, we might say that our mean time to restore, so if we've had a failure, then this is the time it takes for us to diagnose what the failure is, effect the repair, and restore the SIF to normal operation. So we might say it's 25 hours or 72 hours for final elements. So we would, again, measure how long it takes us to do our repairs and restoration. Another metric that the standard requires us to define is a maximum permitted repair time. So for example, if we take a SIF offline and we're still running the process, as soon as we take the SIF offline, its PFD is 1 because the SIF isn't available to perform its function. And so depending upon the SIL of the SIF, the longer it's out of service, the more exposed we are. So we would have to think about alternate means of mitigation while that SIF is being repaired and restored. So the standard requires us to define a maximum permitted repair time. So you could, for example, if we're using our 25 and 72, we might say, well, we'll allow 100 hours as a maximum in case we can't get some parts quickly, or if we have to machine something. So we might say 100 hours, and that would be another one that we would be looking at measuring. to make sure that we're within that window. If we regularly exceed those times, then we need to do a root cause analysis. Why is that? Did we get it wrong when we did the original design and the targets? Did we underestimate the amount of work involved to do that? Are our people not trained well enough to be able to do it in those times? What's the problem? And then we would take steps to rectify the problem. The number of unwanted trips, as I said, is another one. We would need to make sure that we're tracking that. And of course, the SIF response times itself. The SIF response time is defined in the SRS. So if we're relying on the SIF to bring the process to a safe state, is it being able to achieve that in the time that we've defined? And there can be other KPIs that we can use. These are just some examples, but we can use these from the SRS. We don't have to go and create new ones. So that's why if you don't have the SRS, then that should be a question, is why don't we have the SRS? So I've already said the assessments of the O&M personnel and the number of overdue inspections. So if we're set our proof test interval at 18 months when we did our SIL verification, and we're missing that by a couple of weeks, it's not going to be a huge deal to begin with. If we consistently miss by 2 weeks every time, that will soon become an issue. But if we miss by several months, that is already a problem, because it will reduce our risk reduction for the SIF and could even mean that we drop below our target. So we have to make sure we keep within that. And you can use tools. So the SILStat tool, for example, if you've used Excellencia to do your SIF modeling and your design, you can pull all the data out of this for the SIS and the SIFs into SILStat, including the proof test procedures, because the Excellencia tool will automatically create a proof test based upon your equipment selection. So it uses the manufacturer's recommended proof test to achieve a certain coverage. So the tool does it for you because it looks at the equipment, it figures out what the overall coverage is going to be for the SIF, and it applies that coverage. Now you can of course override that if you believe your proof test that you've created is better. And remember, the coverage is an indication of how well the proof test, how effectively the proof test can help us find dangerous undetected failures that the diagnostics have not been able to find. It's not to prove that the SIF works. So that's number one. The proof test is not to prove that SIF works. It's to help us find potential dangerous undetected failures that the automatic diagnostics haven't found. So if you've developed a procedure that is better, then you can use that number. If not, you can just use the Excellencia number, and that will automatically be applied in the SIL calculation. So that information can be automatically pulled into the SILStat tool, and then you can use the SILStat tool on a tablet, for example, and go out in the field, do the visual inspection, run the proof test, record all the results, and post it back up to a central server. So it does it for you very nicely. And then you can see through the dashboard which SIFs are coming up when for their next tests. The other thing is the test documentation. Has that been completed correctly? So these are important because with the assessments, what we're trying to do is minimize the potential for systematic errors creeping in. And those of you that have been on the FSC 100 class before will know when I mentioned the 3 Ps. I always try and characterize things to make it easy to remember. So when it comes to systematic issues, if you think about it as the 3 Ps, the 3 Ps being, firstly, the people. Are our people properly trained and qualified to do the jobs we're asking them to do in relation to the safety lifecycle activities. Secondly, do we have written procedures that are being followed? There have been too many instances of accidents, major accidents, where startup procedures, for example, were violated. And as a result, the corners were cut, and this led to a contributing factor to the ultimate accident that occurred. So procedures, if we're not going to follow procedures, there's no point having a procedure. If the procedure isn't being followed, then we need to know why. Is the procedure incorrect? If it's incorrect, then we should be able to quickly address that to avoid a potential systematic issue. The third P is the documentation. Do we have a documentation trail to prove that we're doing what we said we were going to do? So here again, the test documentation, has it been completed correctly? If you're using the tool, that's easy to do. If you're doing it manually, then oftentimes it's how quickly, once the test has been done, is that information loaded into either an SAP system or some sort of asset management system. We also need to, as I mentioned before, look at the number of near misses. So what's a near miss? Well, let's say we have an upset that causes an overpressure situation and our mechanical relief valves are activated. We don't actually have an incident per se, but the fact that the valves went off in the first place is an indication of all is not well with the process. So we should be counting those, looking at what's causing them and looking at ways to reduce that. So what needs to be measured? So when we were doing the design, as I mentioned, there are key parameters that we define and that are used in part as part of the proof test, the SIL verification calculation. Proof test intervals, as I've said, that's number one. How frequently are we going to do the proof testing? And here again, we must be realistic with this. We had one client that came to us because the engineering company, in order to meet the SIL target with the mission time that has been specified, used a 3-month proof test interval. And the end user couldn't they just weren't set up to be able to do that. They didn't have the manpower, they couldn't possibly do it in 3 months. So of course they were set up to fail before they started. So as another thing, when I teach the class, I always tell any engineering members or who do SIS design is don't design in isolation. Talk to end user maintenance people, find out the sore thumbs when it comes to maintenance, and don't set proof test times that are unrealistic and will not be able to be achieved because you're just setting them up to fail. So the frequency of the proof testing is very important. Are we doing it on time is very important. And are the proof tests as effective as originally intended? In other words, are we using the same proof test procedures? So if you're not using Excellencia, then you need to refer to the safety manual. And here again, oftentimes when I talk to end users, they are not provided with the safety manuals for the equipment. So 1508 requires the manufacturer to create a safety manual. It doesn't say the manufacturer has to provide the safety manual free of charge. And in fact, some do charge for certain parts of the safety manual. Also, the safety manual may be part of another document or set of documents. But either way, the safety manual contains very important information. It contains information on the failure rates. It contains the useful life information. It contains a recommended proof test to achieve a recommended coverage. So again, if you don't have a tool like Excellencia, then what you need to do is have access to the safety manual to be able to create a proof test procedure for the SIF. And of course, there'll be different components in the SIF, and each of those components will have their own safety manual, or should have their own safety manual. Even if a device is a prior use justified or proven in use justified, it still needs a safety manual. Another example could be diagnostics. If the device has the capability of running diagnostics internally or being run externally, there might be some configuration that needs to be done. If this isn't done during the installation and commissioning, then you may be working under the fallacy that the diagnostics is running, and we've taken credit for the diagnostics in the SIL verification part of the design, and we're not running them. So again, without the safety manual, you won't know that. The operation and maintenance personnel assessments. So are we doing the training? Are we tracking competency? So another important change in the 2016 edition was more emphasis now on roles and responsibilities being defined so that people know what their role is from a functional safety perspective and life cycles perspective. Also, what is their sphere of authority and responsibility? What's expected of them? Because again, without that being properly defined, things can fall between the cracks and we end up with potential systematics again. So we need to make sure that's done. We also need to define and track competency. So we need to either have some form of competency rubric or some RACI chart, but we need to record competency for each of our personnel, and it needs to be tracked and it needs to be managed. So there needs to be a competency development program that's ongoing. So these regular assessments need to be conducted. But again, as I said, the standard doesn't tell you how frequently to do that. You can look at it, the performance again of the O&M people as well as the SIS, and if the performance is being maintained, then maybe you need to do it once a year. If we're having problems, of course, you would probably want to do it more frequently. But again, as I said, the standard doesn't define how often you need to do that. In terms of the events that we need to be recording, will be demands on the SIS, whether these are real or false. And again, if they're false, why is that? Is it because we've got equipment failing? And we would need to look at, if it's equipment failure, what's causing the equipment failure? Is it because the equipment, same thing, has it been installed properly, configured properly? Is it suitable for the environment, the application, and so forth? And then any incidences or near misses need to be recorded. Failures both from a random and a systematic point of view. Random failures are used in the PFD average or the PFH calculations we do. And so we need to make sure that we do record properly failures. And the general rule of thumb that we use is that all failures are random until proven otherwise, because sometimes in the field, a lot of failures are miscategorized as being systematic when they're not. And systematic failures are not included in the PFD average or the PFH calculations. Proof testing. As I said, we need to record the fact that we're proof testing and the results of the proof tests. And if a proof test fails, then we have to follow the procedure for doing a proper assessment, root cause analysis. What was the reason why? And then if we have to make a change, then we have to follow management of change. But before we implement the change, we need to do a safety impact analysis. And again, that needs to be performed by somebody who's responsible and competent to do that, because they have to assess the impact on safety to make that change. And that could mean we have to go back to the analysis phase. We may have to change the SRS. So that needs to be understood. The repair and restore times, are they within the specified times in the SRS? Are we exceeding our maximum permitted repair times, as I said? And are our procedures being properly followed or not? So if the procedures are not being followed, as I've said, we need to understand why. So why isn't this being done? It's an interesting question. In Australia, for example, it is a legal requirement for end users to perform this. So we're seeing a lot done in Australia, but over here in the US, we haven't seen that many. We had a request to do one in the last two and a half years. So it seems to me it's very strange that the end users do not seem to either want to do this or seem to feel the need to do this. And again, it does come down to overall culture of the company. If the company culture is one of we are interested in maintaining our standard of care, then we should be doing this. If it's a culture of minimum operating expense, minimum budgets, and so forth, then this is going to be at odds, because they'll see this as an unnecessary expense, and then why should they do it? But they don't realize that this is actually a requirement under 1511. And if they come under OSHA PSM, even though OSHA PSM doesn't specifically say you have to follow 1511, it does require OSHA PSM companies to follow RAGAGAP, which is recognized and generally accepted good engineering practice, of which OSHA recognizes ISA 61511 and IEC 61511 as being RAGAGAP. So it's a good idea to look at this carefully. I talk about culture a lot when I talk about safety, because it's very important that companies develop the right culture in terms of being open and willing to learn and being safety conscious. And of course, that has to come from the top. It has to come from the board of directors down the line. If management doesn't buy into this and support the process, then it is going to be very difficult for those who have to implement functional safety, because it'll be like pushing on a rope all the time, because you'll have to be justifying the need to replace equipment as it comes to the end of its useful life, even if it hasn't failed. And therefore, oftentimes the pushback is, well, if it's not failed, why do we need to change it? And part of the reason that I wrote the book, Functional Safety for Managers, What Managers Need to Know, is because I've had so many discussions with management teams, and they just really don't understand. So this is very important. And again, the use of the metrics and following the procedures is very important. Making sure our people are properly trained is very important. And if we do it right, it will actually save time and money. There is a website that we created called the sitesafetyindex.com that you see there. And this is for end users to get a quick feel for how their operations are going. So basically, there's about 40 or 50 questions into different categories, and you get a weighted result that will tell you where you sit within a 5-level, what we call site safety index. So SSI 0 is, bare minimum. They're doing very little. That's what we call the ostrich, burying your head in the sand, just carrying on, run to fail, all of that good stuff. Up to SSI 4, which is really the holy grail, where everything is being done according to data and it's being done correctly. So ideally, most would want to be at SSI 2, which is good, where you're doing most of the repairs on time, you're following through with maintenance and so on. SSI 3 is almost perfect, and SSI 4 is perfect. So this is a good opportunity to get a quick view on that. There are important factors that impact the SIS performance. The equipment selection and qualification is very important. Like I said, we need to not only select the equipment that will help us meet the SIL target, but it has to meet the application and environmental requirements. The testing that's done during commissioning is very important. If we don't do the installation properly and the commission testing properly, we're going to be having problems. The safety validation test, if we don't do that correctly, and remember, the validation test is to make sure the as designed, installed and commissioned SIS and all its SIFs meet all of the requirements of the SRS. So as I've said, if we're taking credit for diagnostics and we're not configuring the devices to run the diagnostics, then of course we're starting off on the wrong foot. The proof test procedures, are they being followed properly? False trips, are we managing our false trips? If we're getting a lot of false trips, we need to understand why. Because when something trips, especially if it's in a refinery, if you've got a $60,000 barrel a day refinery and you trip because you didn't spend or didn't want to spend maybe $30,000 to maintain a piece of equipment, so it's failed and now it's taken your process down and you're down for a day, how much is that going to cost? Well, if it stops you producing 60,000 barrels at whatever it is, $70 a barrel, you can do the math. It just doesn't make economic sense. And yet, this is one of the problems. Don't want to spend the money on proactive maintenance. So you end up spending money on reactive maintenance. And actually, you end up spending more money if you don't do it right. The failure diagnostic and repair procedures also have an impact. As I've said, device useful tracking, life tracking and replacement. Once a device gets outside of useful life, we really don't have a PFD average or a PFH we can count on. We really don't have a SIL we can count on. So this is definitely not something we want to do. And like I said, if you want to know more about that, there's an Exida Explains video that I did on this and also a webinar on this. SIS modification procedures, if we're not following through properly on the modification procedures and doing what is effectively an FSA 5, doing the impact analysis to see what's going to be the impact of the change that we want to make, then again, we could be introducing potential problems. And also at the end of life of the SIS when we go through the decommissioning. So all of these things will impact the SIS performance. So how can we use this data? Well, as I said to you, every 5 years, we have to do a revalidation. So we could utilize the data that we're gathering and feed this back into the hazard and risk assessment. This can help us with looking at whether or not our proof test intervals are still valid or can be extended. If our performance is better than we originally anticipated, we might be able to then look at adjusting the proof test intervals. And if we can stretch the proof test intervals out, then we'll save money on the maintenance. We would also use this as a means to confirm any assumptions we had on demand rates and hazard frequencies to see if it's still valid or not. So we want to compare our actual performance with the assumed performance. So here we would look at, is the risk reduction still adequate? If it is, we carry on collecting data. If it's inadequate and our hazard risk is higher than expected, we would have to return to the analysis phase for redesign and implementation. If it's more than adequate, in terms of the system is over-designed to prevent the hazard, then it gives us the opportunity to make adjustments and gives us potential cost savings. So again, in all cases, anything we collect and the lessons we learn during the operation of the plant can be used for the analysis of any new process systems if we're going to put them in at a later date. So this is another good reason why we should be doing this. What are the consequences of poor SIS performance? Well, we can see it. If you go to the CSB website and look at the videos, you'll see SIFs can fail on demand. That's one of the primary concerns, because if we're not maintaining the SIFs properly, then they could fail when we don't want them to. We could end up with an increase in unwanted trips and of course an increase in maintenance costs as a result. We would increase in the risk and likelihood of a major accident. So every day that we don't do this correctly, we're just building up and building up, increasing our risk gradually every single day. And then, of course, this would give us an increase in the potential for serious injury fatality. And end-of-life devices typically don't get replaced or refurbished when they're supposed to be. So again, run to fail, for example. So all of these things could lead us to have potential significant consequences. And dear old Trevor Kletz who used to say, if you think safety is expensive, try an accident. Accidents cost a lot of money in terms of equipment replacement, litigation for injuries and fatalities, and of course, loss of the company's reputation, all of which can have a significant impact on the bottom line. So just to summarize then, we really want to adopt an appropriate safety first culture where we have trained and competent operations and maintenance personnel. We should be conducting the FSA4. We can do that via the use of independent third parties, or if we have independent qualified people in the company that we can use to do this. The independence is important so there's no bias and it is a true independent view. We want to make sure the right metrics are in place, and then the way to do this is develop a safety checklist to ensure consistency so we don't miss anything. And I'm always, when I teach the class, I'm always going on about my pilot's analogy, my commercial pilot's analogy, in that commercial pilots may have flown for thousands of hours, but every time they get into the cockpit, they don't rely on their memory. They get their pre-flight safety checklist and they run through the checklist so they don't miss anything. So this is another thing that we can do as part of an FSA4. We should develop and maintain some form of leading and lagging indicators so that we can make sure we're doing our assessments on time, our testing on time to avoid future issues, and we should learn from experience of incidents or past events, and then undertake these regular competency assessments. Like I said, the standard doesn't tell you how often to do it, it leaves it up to the end user. We need to make sure that proof testing and maintenance is conducted in line with the SRS requirements. Record all the maintenance activities accurately and faithfully. The use of tools, as I said, can help with assisting in recording and auditing this. And also they can help with analyzing failures, false trips, and actual SIS performance. So this is something that can be very useful to have. Then we can look at reducing unwanted incidences like false trips, for example. We should analyze the performance data and reuse it in our 5-year PHA revalidation. So even if you do it once every 5 years, you should at least do it before you do your revalidation so you can learn from the data that's being collected. You can, of course, do it more frequently. You could do it once every 2 years, once every 3 years. It's entirely up to the end user. So I hope you found that useful. Just as by way of letting you know of any courses that we have coming up, we've got one running right now on FSC 100. And these are all instructor-led half days. We do them these days because 4 hours is probably enough to sit in front of a screen. Then we have alarm management coming up in December, along with the new CS 100, which is our cybersecurity equivalent of our FSC 100 course. And then we have one more FSC 100, which is planned for being an in-person in Stafford, although that one may not run if we don't get enough people. Then for online, there's a list of online courses. I'm not going to go through all of these, but if you want to know more, you can certainly reach out to Exida Academy or just go to the website and have a look. So you can find all the information you need through our social media or email Exida Academy directly. And with that, I will now open it up to questions, and I do see, whoops, there are some questions. So let's see what we've got. Well, the recorded, yes, as I said, all these sessions that are recorded will be available for use through the website. Can number of alarms on high or low be considered as near misses, assuming that they are not false positive and do not result in an actual instance? Well, again, that's a good question because 1511 doesn't really address alarms in any great detail, but here again, if we're going to be doing that. We should really have properly rationalized alarms. So the ISA 182 standard, and I can't remember the IEC equivalent number, that standard is very important to make sure that we identify true alarms. We look at priorities so that under alarm flood conditions, the operators don't get bombarded with unnecessary information, such as alerts or things that shouldn't be alarms. So right now you could do that. You could look at, okay, how many alarms are we getting? The standard, the 18.2 standard recommends no more than one alarm every 10 minutes to give the operator a chance to decide what the alarm is about. And this is why rationalizing alarms is a very good idea, because if you have more than one alarm every 10 minutes, it's going to be very difficult to be able to not only understand what that alarm is, diagnose it, and then treat it. So 18.2 is very clear that an alarm is only an alarm when the operator is required to do something and has the time to do it. So yes, that could be certainly one of the KPIs you could use. What parameters does Excellencia account to recommend the proof test intervals? Does it account the operation time, how often the valve has been used? Yeah, well, Excellencia will account for timing. In fact, when you go to the silver tool in Excellencia, when you've designed your SIF, it will give you a response time. So it'll tell you what the overall SIF response time is going to be. So you can see that. And here again, the 1511 standard now requires process safety time to be listed in the SRS. So we need to know what the process safety time is. We need to know that the SIF response time is going to be well within that process safety time. So proof test intervals, again, how long does the proof test take? The proof test duration. I didn't mention that, but that is, Excellencia deals with all of that. So you would specify how long does it take to do the test, and then that would be accounted for. Does PSM assessment meets the requirements of FSA? Well, in some cases it may do, but again, the 1511 has specific FSA requirements depending on which FSA it is. So if you're going to be 6.15.11 compliant, then you need to be following the FSA requirements that are listed. And here again, we provide templates for doing FSAs, and obviously we provide support to do the FSAs. So you have that, and also in Excellencia, there's guidance as well that you can use for meeting the 6.15.11 criteria. Sitesafetyindex.com is not available. It's interesting. It should be available. To look at that. If the standard is not prescriptive in FSA intervals, how do companies determine this? Best practice, rule of thumb, is there any quantitative way to determine FSA intervals? Is it just qualitative? Well, as I said, this is the difference between a prescriptive and a performance-based standard. The standard says you need to do it, doesn't tell you how often to do it. So it would be a judgment call. Whoever's responsible for process safety would be making that call, because if you're getting a lot of incidents and problems, you don't want to be waiting 5 years before you do an assessment. You want to be doing it fairly quickly to find out what is the root cause. So it is a judgment call, and it will be based upon the site performance. That's why I said the Site Safety Index was a useful tool to initially assess the site performance. The only real way to do it better is to have an experienced certified assessor to come in and look at the site performance and come up with a score that tells you, okay, where are you? Are you SSI 0, SSI 1, and so forth? And of course, we can do that. So your site safety index is not available. You've tried 5 times. I don't know. I'll have a look after this, but can you send me an email and I'll let you know? Because last time I looked, it was available. So we'll look into that. Thanks for highlighting that. Should be available. Any other questions? All righty then. Well, if there are no other questions, I thank you for your attendance today. I hope you found this useful and informative, and I hope those end users out there that are watching this will consider doing FSA4s, because it is an important part of meeting the requirements and ensuring that as we continue to operate, that we continue to operate safely. So thanks everyone. Oh, I see Rudy's replied. It's www.exida.com/SSI. So we will look at that, and if necessary, I'll change it. So enjoy the rest of your day or evening, wherever you are in the world today. And thank you again for attending. Stay safe, and bye for now.